Today we will be looking at Chapter 1, Section 1, Part B, and we are still looking at rational numbers and different ways to represent them. And this time we're going to be changing a decimal to a fraction. And so before we do that, we have to take a look at something called divisibility rules. And there are several divisibility rules that I think are very important to know, and a couple of them are listed here. And so first of all, divisibility rule for 2. Most people know that they end in an even number like 0, 2, 4, 6, or 8. And so it gives you an example here of 168 would be divisible by 2 because 8 is an even number. And divisibility rule for 3, if the sum of the digits is divisible by 3. So if you look at this example here, 168 is going to be divisible by 3 because those digits we have 1, 6, and 8, they add to make 15. And 15 can be divided by 3. So 4 is one a little bit different. It's the last two digits are divisible by 4. So for instance here, 316, the 16 here, the last two digits are divisible by 4. So I know that 4 is going to go into that number. And 5, it either ends in a 0 or 5. 6 needs the rule for 2 and 3 to work because 2 times 3 makes 6. And then 8 is similar to 4 in that the last three digits need to be divisible by 8. And 9, it's similar to 3 in which you're adding the digits. Look at 549 is divisible by 9 because if you add the digits, 5, 4, 9, they make 18. And 9 goes into 18. And the last one here they list is 10, and it has to end in a 0. However, I'm going to end up adding one more. I'm going to say 25. So if a number is divisible by 25, here's the deal. All it has to do is it has to end in double zeros. So for instance, it could be like 100. That would end in double zeros. It could end in 25, so maybe 225. It could end in 50, so that would be like 550. Or it could end in 75. And if I have a number like 375, 25 is going to go into it. And the key is, think of quarters. See, if you have a set of 4 quarters, it makes $1. So you see how $1 ends in double zeros. If you have, let's say, 5 quarters, or actually here, let's say we have 9 quarters, we'd have $2.25. The $2 is the 8 quarters plus the extra 1 quarter makes 25 cents. And here we have 4 times 5 makes 20 plus 2 makes 22. So this would be 22 quarters to make $5.50. And if I multiply 4 by 3, I get 12 plus 3 makes 15. So 15 quarters makes $3.75. So I like this rule whenever numbers end in double zeros, 25, 50, or 75. I like to use that. Now, numbers ending in double zeros, sometimes I'll just divide by the 100 or the 200 or 300 or whatever number goes in there because it makes that a little bit easier. But definitely numbers that end in 25, 50, or 75. Try dividing by 25. We'll have one like that in the lesson today. So let's take a look at it. So again, we are going to be changing these decimals into reduced fractions. And so that's why we needed to know some divisibility rules, because in order to do this, we're going to end up having to reduce. So all you're going to do is you're going to look at the number and you're going to read it off. Now when we read off a number we talked about yesterday, we are going to read it off by reading this number. So 825, erase that number there, 825, and then the 5, we read this place value. And so the place value is going to tell us what number to put in the denominator of the fraction. Well, this is the tenths, this is the hundredths, this is the thousandths. So that means this number is 825 thousandths. And so remember those divisibility rules I just talked about. I like to divide by 25 when the number ends in 25. So that's what I'm going to do here. Now, to figure out what that is, all I'm going to do is think about quarters. So 8 quarters, well, actually, I'm sorry, $8 here, $8.25. Think of it this way, 825 pennies, basically. So $8, how many quarters would that be? Well, 4 times 8 makes 32. And then plus the 1 extra quarter makes 33. So 33 quarters there. To figure out how many quarters go into 1,000 pennies or $10, I would just divide and see how many times, well, actually multiply 10 times 4. And see, 10 times 4 gives me 40. So that's how many quarters I would end up needing to make $10, or 1,000 pennies would also make 40 quarters, be the same exact number. So 33/40ths, and that's already reduced because 33 and 40 have no common factors. So for this next one, I'm going to think of this as a mixed number is what I'm going to do. Because what I'm trying to do here basically is take this 3 and then add on the 6800ths. So all I need to do is change the 6800ths into a fraction. So let's do that. So 3 plus 68 hundredths. Hundredths because, see, there's 2 places after the decimal. The 8 is in the hundredths place. So now all I have to do is reduce. So when I reduce this one, I look at 68. Now, I know 2 goes into there, but I'm pretty sure 4 does too. The reason is that I know 8 times 8 is 64. And I know that, well, if 8 goes into 64, well, then 4 is going to also go in there. And 64 is 4 less than 68. And so that means 4 must go in there. Now, I'm not sure how many times, so I'm going to have to do the division myself. So 4 goes into 6 one time with 2 left over. 4 goes into 28 7 times, so it would be 17. And then 4 goes into 125 times. And then all I have to do is bring down that 3. So 3 and 17/25. So we can write that as a mixed number like this. Now let's take a look at the next one. This is a little bit tougher concept here because now we're dealing with a repeating decimal. And so whenever we deal with a repeating decimal, what we want to do is we want to first note how many numbers are repeating. Now there's only one number repeating here. And so if there's only one number repeating, that means we're going to end up multiply by 10 to the first power, or just 10. And so you'll see what I mean in just a moment here. Basically what we're going to do is we've got this 6 and this 2 repeating. Well, what we're going to do is we're going to try to use a little trick with algebra. We're going to say we don't know what 2 repeating is. So we're going to say x's are unknown, equals 2 repeating. Okay, this is our trick with algebra. Algebra is just basically using letters or variables to represent unknowns. That's what we're doing here. Now we're going to take this and we're going to multiply it by how many numbers are repeating. There's only one number repeating, so we're going to multiply it by 10. We're going to take this equation here, and I'm going to multiply this side by 10, and I'm going to multiply this side by 10. Now what happens is I'm now left with 10x equals, now when I multiply this side by 10, the decimal point moves over one space, but it's still 2 repeating. See, now it's 2.2 repeating. So now what I'm going to do is I'm going to get rid of that repeating, and this is how I'm going to do it. I'm going to subtract the 2 repeating. I'm going to go minus 2 repeating. But I'm going to do it from both sides, because what I do to one side, I have to always do the same thing to the other. But remember, x equals 2 repeating. So if I subtract x from both sides, it's the same thing, because x is 2 repeating. That's what I said it was. And so now I'm left with 9x equals 2. Just 2 now, not the 2 repeating, because these 2 repeatings canceled out. So all I have to do now is solve a simple algebra problem by dividing by 9 to get the x by itself, and I'm left with x equals 2/9. So now I have 6 and 2/9. And so that equals, well, again, 6 and 2/9. And that would be the reduced form there. Well, we're going to do it with a little bit different number this time. This time it's 2 numbers repeating. Now again, you always look for how many numbers are repeating. So here we have 2 numbers repeating. And so what that means is instead of multiplying by 10, now we're going to end up multiplying our little equation that we're going to set up by 10 to the second power. And so that's going to equal 100. Not 20, but 100, because it's 10 times 10. So what we're going to do is we're going to take x, since I don't know what 12 repeating is, I'm going to say x equals 12 repeating. So we're going to use that same trick. We're going to multiply this side by 100 and this side by 100. And what this will end up doing is it allows us to cancel out the repeating amount. So now we're left with, again, the decimal moves over 12, or 2 spaces, so 12.12 repeating. So from this point, We're going to subtract the amount repeating, what is repeating, which is 12 repeating. And on this side, since x is 12 repeating, we said, we're going to subtract x from both sides. So we're left now with 99x equals 12. And so all I have to do from this point is divide. And I'm dividing by 99, and I have myself a fraction which I can reduce. So you see how both of these numbers 3 goes into. So I can divide it by 3, and 12 divided by 3 gives me 4. 99 divided by 3 ends up giving me 33. So my answer would be 4/33. That would be the reduced form. And that's what we do. So that's problems similar to the homework. Good luck.